Yeah, I put it on my computer and yeah, it's so confused.
Yeah. Well, the computer should be a lot easier for you guys to work with.
It's so confusing.
All right.
Submitted it 7 times. I got it circle. Today. I was just like, what the hell went wrong?
All right. So we're going to be talking about symmetry today. Last time we talked about transformations, or translate, rotate, dilate, and reflect. Now we're going to be talking about symmetry. So this is just looking at a diagram or a picture, some sort of figure here, figuring out what type of symmetry it has, and then continuing with a couple more details we're going to learn too. So there are 3 different types of symmetry, right? Our first one is called line symmetry. You guys ever heard of symmetry before? Hopefully.
Line of symmetry.
A figure has line symmetry. A figure is going to have line symmetry if there's a fold line through the figure that creates 2 exact paths. So when you guys were little, did you ever like have a piece of paper and then you put like paint dots or something and then you folded it and then reopened it again and you had that kind of imagery created on the other side?
I used to do that with scissors. Cut it out.
Oh yeah, you'd fold it and then cut it and then open it, right? So that is a representation of line symmetry. If you can fold something exactly in half, and it doesn't matter how you do it, diagonally, horizontally, vertically, if you can fold it exactly in half, that means it has line symmetry. That fold line is called the line of symmetry. And you want to look out for that. Vocabulary. Line of symmetry. A couple different ways that this is going to show up. I may ask you, what is the line of symmetry? So I could have a picture on a graph, and I could say, where is the line on the graph, or you could fold it in half. So you're going to be asked to find the equation of the line that would be the middle. Or I could ask you, how many lines of symmetry does something have? You have to think, how many different ways can I fold it in half? Right? Those are the most often time, or the most frequent questions they will ask you about line of symmetry. So that's symmetry type 1. Symmetry type 2 is called rotation symmetry. Figure has rotation symmetry. If the figure, if you can take your shape and you can rotate it 180 degrees or less, right? 180 degrees or less, and it ends up landing in the exact same orientation as you had it before, right? So think about a star, like a 5-pointed star, right? If you have the top of the star here and the other point here and you turn it so that they switch, if I turned away and then looked back when you did that, would I even know that you moved the star? No, because it's symmetric, right? All the different points of the star look exactly the same. So you could close your eyes and turn it and open your eyes again and you wouldn't even tell that it moved, right? That's rotation symmetry. Hold on, there are a couple different ways of saying this, so I can't remember what I agreed on. Let me check. Magnitude, no angle. All right. The angle of rotation is the smallest degree measure needed for that rotation to happen. Right? So you can rotate something a bunch of different times, right? You could rotate 180 degrees, you could rotate it 90. Whatever is the smallest degree measure turn that you would need to get it to land on top of itself, that's called the angle of rotation, right? This is what you might want to highlight or underline this. This is an important detail. If I ask you for the angle of rotation and you can't physically turn it yourself, the best way to find that is to take 360, which is a full circle, and divide that by the number of sections for your picture. So think about a star. How many points or sections does a star have? 5. So then to find how many degrees you would turn it to have it land on top of itself, you would take 360 and divide it by 5. And that would be the measure that you would turn the star to get it to land on top of itself. It would be exactly the same. Okay? So that's your rotation symmetry. Okay, so you have line symmetry, which is folding. You have rotation symmetry, which is turning. You have a particularly unique type of symmetry, which is called point symmetry. This third one, which is more easy to forget about, so don't forget it. It's called point symmetry if it has exactly 180 degree rotation symmetry. So it's it connects to type 2, right? But it's its own kind of offshoot of that. So if it has rotational symmetry or rotation symmetry, does it have to have point symmetry? No, right? because it has to have exactly 180 rotational symmetry. So if I had 90-degree rotation symmetry, it wouldn't have point symmetry. Right? So think about your piece of paper, right? You have your piece of paper with you. If I had like a circle drawn on your piece of paper and you turned it upside down, would you notice that the circle had moved? No. So that would be point symmetry. If you can just turn it upside down and it looks exactly the same. That's point symmetry. Okay? So some figures have it, some don't. If you turn something upside down, it doesn't always look the same. Like a picture of a house. A picture of a house and you turn it upside down, the roof's on the bottom, you can clearly tell that it moved. It's not symmetric. So some things have point symmetry, some don't. Right? Yes.
Does like a circle technically have all types of symmetry?
Yes, it does. Yep. Yeah, a circle has infinite symmetry of all these types. Right, so 3 different types of symmetry. We're going to practice identifying them based on these pictures, right? So these are some examples of line symmetry. So you can see how the line's actually drawn. That's where you would fold the shape to get it to look exactly the same. This is rotational symmetry. If you guys were to take this picture and turn it by a certain number of degrees, you wouldn't even know that it moved, right? And this is point symmetry. That means that you can turn it upside down and it looks exactly the same. You guys can try it. Take your piece of paper, and when you turn it upside down, these two shapes shouldn't look any different. They would look exactly the same if you turn your paper upside down. That's point symmetry. Okay? So we're going to go ahead and take these figures that we have in this box. We're going to figure out what type of symmetry they have. It could be all 3, it could just be 2, it could be none. And we're going to find a little bit more information based on that. Do you guys remember what the shape is called?
2, 4, pentagon.
It's a pentagon, so that's 5 sides. So my first question for you, let's just go step by step. Does this have line symmetry? Would you be able to draw a line through this to cut it in half?
Yes.
Okay. Can you visualize it?
Yeah.
Okay. Maybe vertically, like right here. Could you fold that and it would be exactly half? Okay. So we know it's going to have line symmetry. We already know that. We can visualize that line of symmetry. But if you guys have line symmetry, you always have to tell me how many and where they are. Is that the only way that I could cut this pentagon in half?
Couldn't you cut it like from that?
Horizontally, like this?
No.
No, if you cut it like this, this point wouldn't end up. It needs to be exactly flat on top of itself. Here? Like this? Okay. So you could start at this corner and go up like that. You could fold it this way, and it would land on top of itself. Are those the only 2?
It's like all the points.
Point to point.
Point to point? Like from here to here?
No. But like
All the points.
All the points have a line? Is what you're saying? So starting at each point, you could draw a line like this?
Yeah.
Oh,
No.
I did not do that right. I apologize. Go away. Go away. Let me try that again. Dang it. Sorry, guys.
You can't spell symmetry. Just trying to spell it.
There we go. Yeah, so you can draw a line of symmetry through every point. If you can draw one line of symmetry like this, you can repeat it all the way around the shape. That's how symmetry works.
There's 4 lines.
Well, see, that's why I put little arrows. The best way to count it, see how there's so many lines everywhere now, it's hard to count them? The best way that I do this process in order to count is when I draw a line, I draw an arrow at the end of each of them. So then I can just count the arrows. So I have 1, 2, 3, 4, 5. And that's actually a rule you guys will pick up. The number of lines of symmetry that you guys have is equal to the little point, the edges, the little angles on the outside. So if you have 5 vertices or 5 points, you're going to have 5 lines of symmetry. Okay? All right, does this one have rotation symmetry? Can you turn it at all and have it look exactly the same?
Yes.
Can you turn your paper at all and have it look?
Turn it 180.
You can turn it upside down and it'll look exactly the same?
Not upside down.
It's not going to look exactly the same upside down.
Rotation.
No, because see how this way the flat line is on the bottom? If you turn upside down, then the point, no. We're still looking at this one. We have to figure out what type of symmetry. Can you turn this and have it look the same? Yes, you can.
Where?
Rotation.
It does have rotation symmetry.
It's like 72 degrees.
Why?
Because 360 divided by 5.
Mm-hmm. That's right. So whenever you guys are trying to find rotation symmetry, you have to tell me how much you would turn the shape in order for it to look exactly the same or land on top of itself. Because this has 1, 2, 3, 4, 5 parts or vertices, you would take 360 and divide by 5. So if you want to write that over to the side to remind yourself, probably a good idea. If I can get my whatever. Sorry, 360 divided by 5. Alright, so then does it have point symmetry? Point symmetry means you can take your piece of paper, you can turn it upside down, and it looks exactly the same as it did when it was upright. No. This does not have point symmetry. Because originally it had this line on the bottom. If you turn it upside down, then it has the point on the bottom. So that means it's not exactly the same. Right? So this just has line and rotation symmetry. Okay? Alright, what about this one? It does have line symmetry. Alright, so let's go ahead and draw those. How can I cut this rectangle in half?
Corner to corner and half.
Corner to corner? Like this, diagonally?
No, actually, no, never mind.
No, because if you folded it, the points would line up. You need the points to line up exactly on top of each other. Hold on, we're still working on line. I need to know where the lines are.
Oh.
And those are in hot dog.
Yep. I only got this version. Got it. You can fold it in half vertically and horizontally. You cannot fold it in half diagonally. If you guys try to take your piece of paper, this is a rectangle, right? If you try to fold it and try to get these two to land on top of each other, it goes all cattywampus. Right? So you can't do that with a rectangle. We're going to learn this more in Unit 8. Yeah, Unit 8, where we're talking about polygons. Have you guys ever heard about the word regular, a regular polygon? No? A regular polygon means that all the sides are the same length. So in order to fold it diagonally, for it to work that way, all the sides would need to be the same length. And that doesn't happen for a rectangle. Right? Yeah, so it would work first. Alright, so this only has 2. It breaks the rule that I was telling you about over here, how the lines of symmetry should be the same as the points. That only works for a regular figure. This pentagon had sides that are all the same length. So that's why we can use the vertices to count. When it's irregular, so not all the sides are the same, you just kind of have to visualize how you can fold it. So this one has 2. Does this have rotational symmetry? Can I rotate a rectangle and have it look the same?
No.
Yeah, you can turn it 180 like this, and it would look the same. So if it's 180, it's still rotation. Nope. 90 degrees would mean you would turn your paper like this. Does it look exactly the same when you rotate it like that? 90 degrees, we have a suggestion of 90. If you turn the rectangle like this, see how it's now upright? That doesn't look the same as this one. It's flat. So you have to turn it all the way 180. So it has rotation symmetry of 180 degrees. What does that imply? It has point symmetry. Because remember, if it has 180 degree rotation symmetry, that means it also has point symmetry.
I think it's 72.
Over here, because it is a regular figure, the angle of rotation is the number of vertices, or 360 divided by the number of
How are we
vertices.
gonna know if it's a regular?
You can tell all the sides are the same. This one is very obvious that the sides are not the same.
Oh, it's a bit up inside.
Yeah. Alright, what about this one? Does this have line symmetry? Could you draw a line and get it to fold in half?
Yeah, you can.
Okay, where?
Right down. Right down.
Where?
The point at the top.
Here?
Yeah. And then
2.
straight down.
Like this?
No. The other point.
Like that?
Yeah.
Like this? So if you fold it across that line, you would end up
Yeah.
And the other one
going
is
that
straight.
way. Like this?
Yep. Not straight. Hey, shut up.
It looks like a kite.
It is a kite.
How big?
It is a kite. And a parallelogram is a kite. Alright? So how many lines of symmetry do I have? I have 2. You don't have any horizontal or vertical ones because they're not going to line up. The points are not going to land on top of each other if you try to fold it. Does this have rotation symmetry?
Yeah.
Okay, so if you take your piece of paper and turn it upside down, would it look exactly the same? Yes, it would. So rotation.
Is it rotational or is it rotation?
Either is fine. If it has rotation of 180, what does that also mean? Point symmetry. Alright, so here's a question before we move on to the next one. Can you have point symmetry without rotation symmetry?
No.
No. Because you need to have rotation symmetry of 180 before you can get point. So make sure you don't accidentally say it has point symmetry without also mentioning that it has rotation symmetry. That's very important. Alright, who remembers the name of this one?
Hexagon.
Yeah, hexagon for 6 sides. Alright, this is a regular shape. All the sides are the same. So how many lines of symmetry would I have?
6.
I'm going to have 6. Because when it's a regular shape like this, the number of lines of symmetry is equal to the number of points. Alright, and I want you guys to draw them. So what's one way that I could cut this in half? Half like this.
Top to bottom.
Top to bottom like this. Notice I'm putting little arrows on the end so I can count them easily.
Top left
Side.
Here,
the bottom right corner.
like this.
Yeah.
Alright, I can
And then
along
top
back diagonal.
Bottom left.
This one. Okay, that's 4. There should be 6.
The other way around. That's the bottom left arrow up.
Here, that's the same line. There are 2 more. See them?
Below the middle.
Below, like this?
Yeah.
I look like I cut it in half.
You gotta go from in between the line, right there. Oh, in between.
Here?
And then straight up.
Like that?
Yeah.
Okay,
And then the other
That's
one.
what I'm thinking.
And then the, yeah.
like that.
I was gonna say that, I just didn't want to take a slow.
You can go from point to point or middle, like midpoint to midpoint. That's always a possibility. So these last 2 that I drew are kind of going halfway through the shape through the midpoints of the sides. Which I know is a little bit hard to see, but we did that with the vertical and the horizontal, so you can also do it diagonally. So there's your 6.
Wait, but this has rotation symmetry of 60 degrees. I mean, does it have rotation symmetry of 60 degrees?
Why?
Because 60 divided by 6.
Alright, so hold on.
Wouldn't it also have point symmetry though?
Well, you're going a little bit fast. Hold on. Does this have rotation symmetry?
Yeah.
It will. If it's a regular shape, it will always have rotation symmetry. You just gotta tell me how much. No. Of course, everything has 360 rotation symmetry. It has to be 180 or less, right? I need the smallest one, smallest possible. Okay, the process for finding the smallest possible angle of rotation is taking 360, which is a full rotation, and dividing it by the number of corners that you have, or the number of sections that you have. So 360 divided by 6 would be 60. So you can take your shape and move it 60 degrees, which I know you guys can't really do yourself, but 60-degree rotation. Can I also turn it 180 degrees and have it look exactly the same? Can I take it and turn it upside down?
Yeah.
So does it also have point symmetry?
Yeah.
Yes, it does.
Oh,
Because you can do 63 times
yeah.
to get to 180. So it doesn't have to have just this, right? It can have more types of rotation and still be point symmetry. Just keep that in mind. You could have a smaller than 180-degree rotation and still be able to add up to 180.
Oh, so you could have like rotation symmetry of 10 and it could still have point.
Because you can do it 8 times. Yep. Or sorry, 18 times. Yeah. All right. Is everybody good with the first couple of examples?
Yes.
All right. Last one. Okay, so we think it as line symmetry. Is this a regular shape like we were seeing with this one and this one? It's not, alright? So we have to think a little bit differently about the lines of symmetry. How many lines of symmetry can you guys see like automatically? Okay, so you can see 2 really easily. You have a vertical one and a horizontal one.
I can see 4. Oh, you can go
But are
straight.
there more?
Yeah, there's 4. There's actually 4.
So you can go out like this, right? You can fold it over like that.
Good.
You can also
Yeah.
fold it like that.
Anyway,
Yeah?
sure.
So how many was that total? 4.
Ah.
Yeah, the abstract figures, you have to really think about it really carefully because they don't have that special rule like these regular ones do. So just think carefully. Well, hold on, if you rotate your first, can you rotate this?
Yep.
How many different points do I have? I have 4 different points or sections. So if I have rotation symmetry, can I turn my page and have it look the same? You can turn it 180, but for rotation, you want the smallest one you can.
90.
360 divided by 4, which is 90. Remember, to find this, you do 360 divided by the number of sections or points that you have. In this situation, it's 4. So 360 divided by 4 is 90. Now, that's the rotation symmetry, but can I still turn it 180 degrees too and have it look the same? Yes, I can. So this would also have point symmetry. Right? So don't assume point symmetry. Always do line and rotation first and then follow up to see if the rotation symmetry also includes that it's point symmetry. Remember, point symmetry is when they have 180. You can turn it upside down. Is everybody okay with those examples so far? Okay. Now we're going to get into some kind of stranger looking figures. Right? These aren't like hexagons and pentagons, they're actually little designs. But we're going to do the same thing. Right? For this one, we're going to focus on rotation symmetry specifically. So I want to know all the different rotational symmetries between 0 and 360 that I can use to have it look exactly the same. Right? These are more abstract. Remember, to find the smallest rotation, what do? To find the smallest rotation, you would need to turn it for it to look exactly the same. What do? You would take 360 and divide by the number of points or sections, right? This doesn't have points, this has the sections, so I was using that word too. So how many different repeated sections do you guys see in the picture? Which in this situation, because it's a flower, you would think of in terms of petals. 1, 2, 3, 4, 5, 6.
Oh, so you don't count the other one? I can't explain.
Well, they kind of go together. Like this is a section, this is a section, right?
One petal.
So one petal and its associated little leaf thing.
The inside thing.
Right. So we have 6 sections here. So what would the smallest turn that I could make be? Yeah, it'd be 360 divided by 6, which is 60. Is that the only amount that I could turn it and have it look the same? Could I do another 60 beyond that?
Yeah.
What would 2 60s be? Okay, that's what we're doing here. We're listing all of them. So I could turn it 60. I could also turn it 120. What if I did it 3 times? 180. What if I twisted it 4 times? And it would still look exactly the same, but how much would I have done?
300.
Oh.
It would be 180 plus another 60. And then 240, and then turn it another 60 degrees. And then add another. You get to your 360. So it would take 1, 2, 3, 4, 5, 6 turns to get all the way around, which is why we use 360 to divide and find the angle measure. Okay? Alright, this one's a trick question. This next one. This one's in that, how many sections do you guys see?
4.
It looks like there are 4. Okay? But you need to be careful with this one. Hold on. Remember I was talking about the regular and irregular? This one looks very circular, right? Right? The closer it is to a circle, the more regular it is. But you guys see how this one is longer horizontally than it is vertical? This is it's elongated along the horizontal axis. So this is not a regular shape. So you do not have 1, 2, 3, 4 different sections. Do you guys see how this part is different than that? The full section is out there, and then this one is kind of sunk into the diagram. So they're different. Yeah, it's like a rectangle. So we have to treat it a little bit differently. If you imagine this is a rectangle, so I'm going to actually draw that.
I was thinking in my mind.
Yeah. It's a rectangle, so you might want to actually draw that. Yeah, it looks like a flag now. So we have a rectangle. So what would the rotation symmetry be for this one? How can you rotate a rectangle to have it look exactly the same? 180. So a rectangle only has point symmetry. So this one, all you could really do was 180 and 360. For this shape, I want you guys to add a little bit of handwritten notes for me, please. Underneath this shape, I want you guys to write a note reminding yourself that rectangles or elongated shapes cannot use the 360 division rule. So rectangles or rectangles or elongated shapes that are not regular, you cannot use the 360 division rule. One more time. Rectangles or elongated shapes, you cannot use the 360 division rule. Right? You kind of have to eyeball it, kind of go from your kind of observation with that one. Right. What about this one? Does this one look circular? Does this look more like a circle or a rectangle? It looks more like a circle. If it looks more like a circle, that means it's going to be a regular shape, and you can use that 360 division rule because 360 is for a circular kind of rotation. How many different pieces or sections does that have? Three. I have this one, I have this one, and I have this one. So it's 3 different parts to it that have the repetition there for the symmetry. So how much would I need to rotate it in order for it to look exactly the same? If I only have 3 sections. You do 360 divided by 3, because I have 3 pieces. So 360 divided by 3 is 20. That would just be 1 turn. How about if you do it twice?
240.
All right, how about 3 times?
360.
Yep. So all the different ways that you can turn the shape and have it look exactly the same. All right, does this one look regular? Is it more circular in shape or rectangular? It's more circular. It kind of goes around in a circular fashion. How many different sections do I have?
5.
1, 2, 3, 4, 5. So 5 different sections. So what would my first little amount of turn or rotation be?
Start in the middle is helpful. Oh, I didn't even notice that.
Oh yeah, let's start in the middle.
72 degrees.
72. So 360 divided by 5 gives you your initial turn, which is 72. You do that twice. 144. 3 times.
260.
260?
60.
16.
They're weird.
I know, it's because of the similar, it's not a... And then you add another,
And then 360.
and then you get to 360? Yeah. So one more time before we move on to this. For rotational symmetry, listen please. Wait, so you guys are paying attention. Yeah. When you guys are looking at rotation symmetry, if it has that circular setup with the shape, then it's going to have that 360 division rule to find the angle of rotation. If it's elongated, it's more rectangular, you have to eyeball it to figure out what you would do. And it's almost always 180 degrees. Right, sometimes it can be 90, but not often. More often than not, it's just 180 and then 360 for the elongated. All right. All right, let's take a look at some SOL questions you guys might see. Symmetry. The new testing stuff doesn't apply until.
It's just practice, right?
I don't remember. You can ask your counselor. I don't know all that stuff. Anyways, so this is a question talking about line symmetry. All right, I have rectangle. This is one of those oblong ones that we have to be careful with. Rectangle ABCD is placed on the coordinate plane as shown. Which equation here would be a line of symmetry? So remember, it has to be a line that cuts our rectangle in half. So the first thing you guys might want to do is actually draw them, right? Would you know how to draw them on here? Where would the line of symmetry be? Or how many are there? The oblong ones, you have to be careful. It's only 2. So maybe you cut it in half this way, right? Grab that one. That was easier to see. And then how can I, well, but where? You have to count very carefully, but where? Like here?
Oh, shit.
Count very carefully. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Yes, like right here, maybe. So you have 5 on each side, right? Yeah, so make sure you're counting. Don't just randomly draw lines. Make sure you're counting so it's right in the middle. So I have my 2 lines of symmetry drawn, so which one of those equations over here matches with this? X equals 2. Y equals 5. Does everybody agree with that one? Remember, y equals is a horizontal line. So y equals 5 is this one right here. If it's a horizontal line, it's a value of 5 on the y-axis. Right? That's how you know how to graph with the y equals and x equals stuff. Everybody get that one? Alright. I have a right triangle with the line measures of 3.5. What is the maximum number of lines of symmetry? How many lines of symmetry can I draw?
One.
Where?
No. From the point up to whatever that number is.
Here?
No, the other one. No.
5 to B.
Yeah.
Like this?
Yeah.
You're saying I could cut this in half? This?
No.
Would I be able to fold it? Yeah. This one's 4, that's 3. Can you draw a line?
You ain't doing nothing. You can't do nothing.
Can you draw a line to cut that triangle in half? No.
Zero.
Because all the sides are different, you can't cut a scalene triangle in half. So all the sides are different lengths.
Not even the other line is different. Those are just numbers.
No, 3, 4, 5, let's talk about the lengths.
Yeah, I
Did
can't.
everybody see how I did that one?
Yeah.
I would like you guys to take a look at these letters of the alphabet.
Top.
Which one does not have line symmetry? T does not have line symmetry. I can draw a line to cut a K in half.
Yeah. It's like a butterfly.
How about you not do that today, Ford? Alright. I can cut the K in half, you're right, it does look kind of like a butterfly. What about 7? 7T.
Yeah, you can correct.
Alright, you can, like that. Hey, kind of looks like a 7 when you cut it in half, right?
Yeah. Look how the feet, they're like turned outward, like elf, like.
You
How do you have
can
imagination?
cut an O in all sorts of different ways, depending on how they draw it with handwriting. But can you cut a P in half? No. So that's our choice. That one does not have line symmetry. Make sure you guys are really careful looking for the word not. Listen. Read very, very carefully for the word not in the directions. Alright, puzzle pieces. Circle the one that has both point and line symmetry. So that means you can draw a line to cut it in half, and you can turn it upside down and it looks exactly the same. So I can cut this one in half too?
Well, don't have an outie and an inch.
Yeah.
No.
So you can't flip it upside down? What about this one? I can cut this one in half. So you can't flip it upside down and look the same? Same with that one. This is the only puzzle piece that I can cut in half, and you can either do it horizontally or vertically. And I can also turn my piece of paper upside down and it looks exactly the same. So everybody understand what I mean by both line and point symmetry?
Yeah.
Alright, I have not provided a visual for this next question. How you can draw it yourself, right? How many different lines of symmetry does a square have? So imagine a square. What do you know about the sides of a square?
Symmetrical.
That's my best representation. What do you know about the sides of a square? They're all the same. So remember when I was talking about earlier about regular shapes? Regular shapes have sides that are all the same. How do you guys figure out how many lines of symmetry you have for a regular shape? It's by counting the corners. Well, it should be the same. Sides and corners are being the same. But how many different corners or sides does a square have? So how many lines of symmetry should it have? 4. And if you would like to visualize them, they look like this. Okay, that's what all the lines would be. So just one more time, for a regular shape, when all the sides are the same, the number of lines of symmetry is going to be equal to the number of sides or corners. What if I made that a rectangle? Would it still have 4? No. So again, when you elongate it, so it's not regular anymore, you have to work a little bit differently with that. Alright, now I am very upset with how this always prints out in your guys' notes like they're invisible. You can hardly see them.
I see that.
They're very hard to see.
The last one.
So I know the last one's really difficult. So if you guys want to like trace it, this is kind of what they should look like.
I found the last
The
one.
first one is kind of like a bow tie. Hold on, this one is like, I don't even know.
font, right? Just put it on the
Oh,
different color.
yeah, it's like the, remember like the things in Fortnite, yeah. Oh, let's forget that.
Picture was kind of paragraphing.
Yeah, I have so much
Okay,
energy.
that's what the last one should look like.
You're so good. I am definitely.
Go ahead and trace or shade it in. That's what all the shapes should look like. I know they print out.
I messed up.
It looks like a gummy bear. The last one looks like a gummy bear.
Yeah.
And it was
Oh, I thought it went down too.
I think they all, don't they all have?
No.
So hold on. The question's asking which polygon has lines of symmetry here and here. So I have a vertical and a horizontal. You guys need to graph those lines in each of these pictures and see if they actually cut the shape in half. So for our first one, x equals -1 would be right here. Remember, x is a vertical. Does this vertical line, x equals -1, cut the bow tie in half? Vertically it does. Cuts it in half this way, right? But the question's asking it has to work for both. So if you guys graph y equals -2, which is right here, does the horizontal line go halfway through? No. So this is not it. Moving. Moving. All right, the next one over. So if I try to graph x equals -1, does that go right through the middle? Well, if you count, I have 1, 2, 3 on the left side and only 2 on the right side. So did it go?
No.
No, so this one doesn't work because the vertical line doesn't work for us.
Can it be like two? Can you do negative? I mean -1.5.
No, they'll never give you decimals. They won't. So in this one, they gave you a specific number and it didn't work out. So you just move on. All right, what about this one? If I go to -1, does that cut it in half vertically? And then if I do -2, does that cut it in half horizontally? Okay, so that's the one we want. That's the one we want. You guys still, I mentioned this last time, you guys have to know how to graph lines that start with y equals and x equals, vertical and horizontal lines. You have to know how to do that. That's not a rule still. You can't do stuff from this unit unless you know how to do that.
I started struggling on that a little bit. My guys flip flop yesterday.
Well, gotta work on it.
They got some set.
Alright, does anybody have any questions about symmetry, whether it's line, rotation, or point? That's pretty much what you guys are going to see in terms of... Is everybody good? Yes? Okay, so what I want you guys to do now is while I'm wrapping up with my computer, finishing the video, and transitioning, I want you guys to work on the graded assignment for a little bit. Maybe about 7 minutes. And then once I get everything set up for a transition, I'm going to have you guys work on math space a little bit. And try to figure that out. And then we'll wrap up by taking a look at the Right? So go ahead and pull out the graded assignment. Go ahead and start working a little bit. And then once I get everything set up, we'll transition into math space.
Oh.